fire and water. Together they make steam, one of man's most useful forms of energy. The engineers of ancient Alexandria knew its power. Today, engineers have harnessed that power to perform the tasks of man in ways of which the ancients would not dare to dream. Modern technology uses steam most effectively by converting it into electrical energy, which can be transmitted hundreds of miles over high voltage lines and used in thousands of ways, in homes, on farms, and in business and industry. Wherever man finds fuel and water together and in good supply, he has the materials for generating electric power at low cost with steam. Such a place is western Kentucky. The Green River provides the water, and the adjacent land contains huge reserves of easily mined coal. Near a tiny village named Paradise, the Tennessee Valley Authority in 1959 began building a steam electric station with 2 great turbo generators. They were the largest of their kind in the world when operations started in 1963. TVA is an agency of the federal government concerned with economic growth through resource development. It has harnessed the Tennessee River system with multi-purpose dams which provide flood control, navigation, and electric power. It has worked with the people of the valley to improve their agriculture and to restore their forests. This combination of resources has helped encourage industrial growth. Economical rates, established at levels as low as sound financial practices will permit, have helped increase the use of electricity on farms and in homes. The federal government itself uses a large share of TVA power in atomic and other defense plants. The power system of TVA serves an area of 80,000 square miles in 7 southeastern states. Hydroelectric power produced at the dams regulating the Tennessee River system was TVA's first source of electricity. Transmission lines connected the separate hydro stations so they could be operated as an integrated power system. As the power requirements of the region and national defense increased, the generating capability of the river system was surpassed. The necessary additional power had to come from coal-burning steam plants. The Paradise plant was built to provide a sure supply for the growing markets in the north-central section of the region, including Nashville, Paducah, and their surrounding industries. Traditionally, steam electric generating plants have been built close to the markets they serve, with fuel transported to the plants. In contrast, the Paradise plant was built actually on top of a coal field. This cut the cost of transporting fuel to a bare minimum. The electricity, rather than the fuel, is transmitted to the large consuming centers. Thus, TVA went to work to develop this combination of coal and water to keep its generating costs low and to assure the people of the region the use of electricity at low rates in developing their economy. TVA designs and builds its dams and steam plants largely with its own forces and equipment. Experience gained by both engineers and trades and labor personnel keeps down costs. TVA also achieves economy and more effective use of expensive construction equipment by moving it from project to project. Almost 5 million yards of earth and rock were ultimately involved in site preparation at Paradise. Good highway and rail facilities help make the location attractive. "31,000 tons of coal had to be mined during the excavation of the powerhouse basement. The powerhouse rests on a solid sandstone foundation, a geological factor important in the site selection. The rains, mud, and snow of the 1959 winter were taken in stride by the hundreds of workers. Buildings to house administration and construction activities were brought in from other projects and reassembled. They were the workshops for many of the 15 different crafts who worked there: boilermakers, millwrights, steam fitters, and carpenters, teamsters, lathers, laborers, and operating engineers, sheet metal workers, machinists, iron workers, and electricians, with painters, bricklayers, and cement masons to finish it off. The central concrete mixing plant supplied nearly 140,000 cubic yards, most of it for the powerhouse basement and main foundations. The plant was designed to weigh and batch materials automatically. Placement was accomplished with a 75-ton crane set on a gantry 100 feet high. Steel reinforcement proceeded stage by stage ahead of the concrete placement. The concrete at Paradise contains fly ash from another TVA steam plant, replacing about 20% of the Portland cement normally required. It not only makes a stronger, more workable, and better-looking concrete, on this particular project, it saved nearly $100,000. Structural steel erection is always a struggle between the workmen and the mammoth girders and columns they must handle. As in nearly all steam plants, the boilers were suspended from the top of the structure. One of the most difficult design problems stemmed from the fact that the Paradise boilers were unprecedented in size, weighing over 9,000 tons. The huge girders from which the boilers were hung were 16 feet deep, 80 feet long, and weighed over 80 tons. Too big to be shipped in one piece, they were brought in by rail in 2 pieces and assembled at the site. Bolting rather than riveting was used in erecting steel. It is faster, safer, cheaper, and more reliable, and fortunately, much quieter. So, as the days ran into months and the seasons changed, the skeletal outline of the Paradise steam plant rose skyward to dominate the landscape. Paradise is an example of TVA's conviction that efficient operation and maintenance can be expressed artistically and aesthetically. The dark brown metal siding surmounting the light brick base defines the various functional elements of the plant. Landmark features of the project are the 600-foot twin chimneys. They are 45 feet higher than the Washington Monument. Built of concrete and lined with brick, they have an outside diameter of 44 feet at the ground level, 26 feet at the top. The extreme height assures that fly ash and gases from combustion are adequately dispersed into the atmosphere. A microwave reflector makes the chimney a useful part of the power system's communication network. The orange and white bands and lights at night serve as warnings to aircraft. To condense the steam used in the 2 turbo generators at Paradise requires almost 500,000 gallons of water a minute, nearly twice the needs of the city of Los Angeles. Tunnels with diameters of 11 feet, concrete lined, carry the water of the Green River to and from the condensers. Thousands of thin-walled brass tubes, extending through the condensers like holes in a thick sieve, carry the water for condensing the surrounding steam. Cooling the steam quickly reduces the pressure in the final stages of the turbines to a near vacuum. Thus, the colder the condensing water, the more efficient the turbo generator. Upstream from the plant is the intake channel, bringing the river water to the pumping station. Dredging was necessary in excavating this channel. To take advantage of the cooler waters at the bottom of the river, a skimmer wall was built at the channel entrance. It's like a dam on legs. The legs, steel cells filled with concrete, allow the cold water to pass through the bottom. While above, precast concrete beams form a barrier, holding back the warmer water at the top. This wall also acts as a trash boom. In addition, to divert the cooler bottom water from the river into the intake channel, an underwater dam was built across the river just downstream. It was made of dumped rock, with the top elevation low enough to permit commercial barges to pass safely above it. Water used in condensing is, of course, returned to the river, unchanged in its chemical quality. Paradise boilers were the largest in the world at the time they were installed. Structurally, the continuous tubing which encloses each of the furnaces is a huge box 163 feet high, 63 feet long, and 32 feet wide. Each boiler produces 4,900,000 pounds of steam per hour, consumes 300 tons of coal an hour, and operates at a pressure of 2,400 pounds per square inch. Its design is the once-through single reheat type. furnace walls are membrane constructed, 1-inch tubes with 1/4-inch steel bars welded between to form a continuous gas-tight wall. A novel construction technique worked out on the job was the erection of the air preheaters. These giant assemblies, made of 2-inch tubing, form a structure about the size of a 10-story building. Normally, the assembly of these sections would take place high above ground. Engineers at the site devised methods of putting them together at ground level and raising them into place in great 90-ton sections. The process turned out to be quicker, safer, and cheaper. Water in the boiler tubing is used over and over in its cycle from liquid to steam and back again. TVA was one of the first to employ flash evaporators, the method used at Paradise, to purify raw river water for this purpose. The pressure system forcing the water continuously through the boiler tubing is provided by 2 high-speed feedwater pumps, each driven by a steam turbine of 15,700 horsepower. The steam leaves the boilers at a temperature of 1,053 degrees Fahrenheit. It is conducted to the turbo generators through pipes made of super-strength, low-alloy steel and manufactured by a process similar to that used for big naval guns. Welding the joints in the alloy pipe required special skills. Welders worked in shifts around the clock while the metal was maintained at a temperature of 500 degrees. Each joint required about 65 hours. Boilers and steam lines must be heavily insulated. TVA used cyclone-fired furnaces for the first time at Paradise. Powerful fans provide the cyclone force of hot air, which mixes with the crushed coal within the 14 burners where the combustion takes place. The temperature reaches 2,800 degrees. The molten ash is sluiced hydraulically from slag tanks to large settling ponds. Boiler erection required more man-hours of skilled labor than any other single feature of construction. The first installations in the turbine room were the 2 125-ton overhead traveling cranes. They were tested by raising a railroad flat car loaded with steel. The low-pressure stator, part of the housing of the generator, weighs almost 500,000 pounds and was the heaviest piece of equipment installed. The turbo generators are of the cross-compound type. In effect, each is a combination of 2 generators on separate shafts, but with a single source of steam. Each cross-compound generating unit has a total generating capacity of 650,000 kilowatts. The turbo generator is the final stage in the process of converting the energy of coal into the energy of electricity. 39% of the latent heat energy in the coal that enters the furnace is converted into electrical energy leaving the generator. This is an improvement in efficiency of about 1/3 since TVA finished its first major steam plant in 1942. The Paradise heat rate is about 8,750 BTUs per kilowatt hour. The low-pressure rotor turns at the rate of 1,800 revolutions per minute. The high-pressure rotor at 3,600. The speed at the tips of the low-pressure turbine blades is close to the speed of sound. The space between those blade tips and the surrounding casing is less than 1/16th of an inch. Under these conditions, the alignment of the rotors was one of the most intricate tasks of construction. Stationary turbine parts were lined up to a piano wire stretched on the theoretical center line. Even the minute sag in the wire was accounted for. The accuracy of alignment had to be within 1/20th of the thickness of a sheet of paper. The generator rotors turn inside the tightly closed stator. A hydrogen atmosphere, which provides less resistance to turning than ordinary air, helps in cooling. Steam enters the turbines at 1,050 degrees Fahrenheit and drops nearly 1,000 degrees in temperature as it does its work. Its pressure of 2,400 pounds per square inch drops to less than 1 pound. The coal for the Paradise plant is at its doorstep. All of it will come from within a radius of 5 miles. Loaded into special trucks with a capacity of 100 tons, it is delivered by the contractor over private roads to 2 ground-level receiving hoppers. TVA's cost of coal, delivered here at Paradise, is about $2.80 a ton, less than half the average for all steam plants in the United States. Hoppers receive the coal. This is the beginning of the flow of fuel, which must be able to supply the plant continuously at the rate of 2,000 tons an hour. Conveyor belts transport it to the breakers. The coal breakers are heavy cylindrical steel shells. They rotate like big barrels, tossing the lumps about until they're broken and fall through the 3-inch holes in the shell. Rocks and other unbreakable material are automatically separated and tossed aside. The coal is weighed as it leaves the breakers on another conveyor line. Motors powered from the plant's own generation drive the belts, with their heavy loads at speeds up to 560 feet a minute. Coal coming from the breakers can be diverted any one of 3 ways. If not required at the moment for power generation, it can be carried away for storage. A thick layer of coal was compacted over the 13-acre storage yard as a foundation for the reserve pile. This reserve will normally contain about 700,000 tons, enough to run the plant at full load for 45 days. The same mobile equipment which stores the coal is used to reclaim it for plant use. Conveyors also feed to a second type of storage known as the live piles. These reserves are piled around slotted standpipes 105 feet high and 7 feet in diameter. The live piles provide a 2-day reserve, which is reclaimed automatically, thus permitting the mine to stop deliveries over the weekend. Coal coming from either of these storage points or direct from the breakers goes first to the crushers. Here, it is broken into quarter-inch maximum size, then conveyed to the bunkers of the plant itself, ready for use. Again, there was opportunity for pleasing architecture. The long, gentle incline and the paint and siding used in the general design were planned to give these structures the same clean appearance as the powerhouse and define the path of the coal from the delivery point to the boilers. From the switchyard, power from Paradise begins its lightning speed journey to the consuming centers. The 24,000-volt output of each generator is carried by bus bar to the outdoor main transformers. Here, the voltage is stepped up to 161,000 volts for transmission to the cities and cooperatives which buy TBA electricity. The main power transformers are rated at 375,000 kilovolt amperes, three-phase, and are cooled by oil pumped through external radiators. Each one weighs over 300 tons. Electrical trouble inside the transformers and even hot weather outside can threaten difficulties. In case of fire, an automatic water spray provides protection. The large generators at Paradise required the development of special 161,000-volt power circuit breakers. These are the safety devices guarding against great unexpected surges of power that might be caused by equipment failure, lightning, or other accident. Both oil and gas circuit breakers are used. They can interrupt a short-circuit current in less than a 20th of a second. The buses carrying power to the high voltage lines are aluminum tubing welded in construction. Porcelain insulators, capable of withstanding great surges of power, separate them from the tower structure. Seven of these 161,000-volt lines carry electricity from Paradise to the centers where it will be used. The main control room is the nerve center of the plant. Equipped with automatic devices operated by an electronic computer, its construction was the most intricate and painstaking part of the project. Successful operation depends on a maze of wiring and cabling which extends from this point throughout the plant. Every wire termination is tagged to make sure of its identity and purpose. The recording instrument board records automatically and continuously temperatures, pressures, and other operating factors. Lights and alarms warn of potentially dangerous situations. Faulty equipment can be detected and disconnected automatically in a fraction of a second. Other controls regulate the generator load and the outgoing high-tension lines. Today, this operator keeps tab on the functioning of a plant which alone could supply half the electricity used by the homes, commerce, and industry of New York City. It is part of the power system of the Tennessee Valley Authority, the nation's largest. Paradise was built in the interests of the consumers of electricity. Its great size is symbolic of the efficient modern technology which helps produce power at low cost, so it may be sold at low cost. It uses to maximum advantage the geographic nearness of coal and water. It uses electronic automation to increase dependability and safety, and to save on operating costs. It is an industrial landmark, clean-cut, modern and stately in its rural surroundings. It was built to serve the people of the Tennessee Valley region and the United States.